Hey, this is Mrs. Dellosso, and in this podcast, we're going to continue talking about matter. In particular, we're going to talk about two different types of mixtures, and then we'll talk about the processes of diffusion and osmosis. So, what you're looking at right now is a great flow chart to have on matter. You can determine whether or not your substance that you're observing is a mixture or a pure substance, whether or not it can be physically separated. So we're going to focus more on the mixture side here. The two types of mixtures that we're going to talk about are homogeneous mixtures or solutions and heterogeneous mixtures such as colloids and suspensions. So let's get started. All right, so first we're going to start with homogeneous mixtures, and when we talk about the term homo, it actually means the same. So let's take a look at an example of a solution. So here I have a container filled with water, and dissolved in my water I have sugar. So the water is known as the solvent because it is the substance in which a solute is dissolved. The sugar would then be considered the solute. The sugar is the substance that is dissolved. So the solution would look uniform throughout, the same. And again, the solute would be what is dissolved, and the solvent is the dissolver. Another example of a solution would be blood plasma. Blood plasma is the non-cellular portion of blood, so it contains water, which is the solvent, and then contains other dissolved solutes such as gases, molecules, ions, and even some other substances as well. So solutions, it doesn't have to be limited to just one solute. There can be other solutes that are dissolved, but they're uniformly dispersed throughout the solution. Alright, next we're going to talk about heterogeneous mixtures, and we have suspensions and colloids. The first example we have here is that of a suspension with water and sand. So the mixture still has undissolved solid particles that will settle to the bottom. You can even have some that are floating. So these, the suspension has pretty large molecules. It won't dissolve like that of the sugar in the solution, which we just looked at. And second, here we have something called colloids. The colloid particles are solids or liquids that are suspended in a medium. These particles are larger than molecules like the sugar we saw in the solution, but a little smaller than those particles found in a suspension. It is a mixture of the fine particles that do not dissolve, but they do not settle out quickly. And we have a gel phase, or semi-solid, and then the sol phase, which is a fluid phase. So an example would be like a gel or shampoo that we have shown here. Okay, next we're going to talk about the process of diffusion. Diffusion can be defined as the net movement of molecules from an area of higher concentration to an area of low concentration. And here's an example. So over here on our diagram, we can see that this would represent the cell membrane. And on the outside of the cell membrane, we have a lot more molecules than found within the cell. So there's a higher concentration of solute on one side of the membrane than the other. And because there is this difference between the two sides here, or the adjacent sides, we have what's called a concentration gradient. So the concentration gradient is the difference between the numbers of one type of molecule in two adjacent areas. So because of diffusion, these molecules are going to go from here to here. They want to pass through the membrane going from high to low. You can think about, for example, when you have tea. The tea is concentrated into the tea bag, and once you put it in the hot water, it disperses to those lower concentrations. And that's how you have tea. So let's continue to see what happens in this example. So diffusion causes a net movement of solute particles from the side of the membrane with the higher solute concentration to the side with the lower solute concentration. So in other words, the molecules are going to continue to move from high to low, and even some will move back and forth the other way. But this is going to continue on until equilibrium is reached. So that's when the solute particles continue to diffuse across the membrane in both directions, but at approximately equal rates, so there is no net change in solute concentration. So there will be pretty close to equal amount of solute on now each side. So here's another example of diffusion in action. And in this setup, on the left side we have water, and on the right side we have molasses, and in the middle we have what's called a permeable membrane. So permeable refers to a barrier that allows the passage of molecules. So where is the higher concentration of molasses found? On the right side, right? So predict what will happen based on our definition of diffusion. What are we going to see occur? Well, over a couple of minutes, we're going to see those molecules pass through the permeable membrane till eventually we reach equilibrium, an equal amount of concentration on both sides. So now we'll talk about the process of osmosis. Osmosis is the diffusion of water through a semi-permeable membrane. So semi-permeable, we can also use the terms selectively permeable. So permeable means that it allows substances to pass through. Selectively permeable would mean that it allows only certain things to pass through. So not just anything can pass through a membrane. So let's take a look at a diagram representing osmosis. So here we have our setup once again. On the right we have our molasses. On the left side we have our water. Now since we're talking about osmosis, we're talking about how the water is moving from areas of high concentrations to low concentrations through the semi-permeable membrane. And if you notice, here's our semi-permeable membrane. These molasses molecules will not be able to fit to pass through, but the water can. So that's why we can see that the water can pass through, again going from areas of high to low concentrations. Alright, so that sums up this video, talking about two different types of mixtures and also talking about the processes of diffusion and osmosis. So I hope you found this helpful, and bring your questions to class.